Hey chemistry students, this tutorial is going to focus on the types of chemical reaction when it comes to not only identifying which reaction is taking place when you're given a product, or a reactant or reactants, but also predicting the product. So what is formed? How are the atoms rearranged? So we have 5 different reactions. We're going to use our graphic organizer from class to help us identify which reaction we have taking place. And we will identify that reaction by putting some initials. So an S for synthesis, a D for decomposition, SR for single replacement, DR for double replacement, and a C for combustion. Alright, so let's get started. Number 1, we only have one reactant. We have H2O, or water. So anytime you only see one reactant, you should be thinking that this is a decomposition reaction, because I have a compound that is composed of 2 hydrogen and 1 oxygen. And that's what happens in a decomposition reaction. We have a compound, and what it's going to do is break up into its respective parts. So water is composed of hydrogen and oxygen. So on the other side I'm going to write hydrogen plus oxygen. And the reason why I put the 2's next to hydrogen and oxygen is because they are diatomic molecules. So always remember that about Brinkelhoff. Let's see if I can write it in. So anytime you see one of these elements written out by itself, there's always a subscript 2 with it. Alright, so we did say this was a decomposition reaction, so I'll just put that right here. Right, now we have to balance our equation. We have on our reactant side 2 hydrogen, 1 oxygen. And on our product side we have 2 hydrogen and 2 oxygen. So to balance that out, I see I have double the amount of oxygen on my product side as do on my reactant side. So I'm going to put a coefficient of 2 out front of this water molecule. So now that's going to change my number of hydrogen atoms to 4, my number of oxygen atoms to 2. Alright, so my oxygens are good, but now my hydrogens are off. I have double the amount over here as I do over there. So I'm going to stick a coefficient of 2 out front. Okay, and we're done. Alright, let's move on to the second one. We have potassium plus barium chloride. So potassium is an element. Barium chloride is a compound composed of barium and chlorine. So I'm going to look on my organizer, and I'm looking for an element plus a compound. Right? And I see single replacement, where you have an element plus a compound. And up here too as well with another visual. And what happens in a single replacement reaction is that the element that is coming in, if it is a metal, it will try and replace the metal or the cation in our ionic compound. Now there will be another video about single replacement reactions. We can actually predict whether or not this reaction would happen using an activity series. But this one does work, so we're going to carry on. Alright, so what happens, potassium is going to come in, kick barium out. We're going to have barium out here all by himself. Barium's not part of Brinkelhoff, so I just write the chemical symbol. Alright, and now I'm going to have a compound form between potassium and chlorine. Now you have to go back and remember what you know about ionic compounds, how they're formed. Potassium as an ion has a +1 charge. Chloride, the ion for chlorine, has a -1. So when they come together I have KCl. And we did say this was a single replacement reaction. Right, now I need to balance my equation, so I'm going to erase my arrows. Alright, I have 1 potassium, 1 barium, and I have 2 chlorine on my reactant side. On my product side, I have 1 of everything. 1, 1, 1. And notice I did my chlorines. I didn't line them up. It's okay. All right, so I have double the amount of chlorine on my reactant side as I do on my product side. So I'm going to stick a 2 coefficient out front of that potassium chloride. So now I'm going to have 2 potassium, 2 chlorine. So to fix that over here, I'm going to put a 2 out in front of this potassium. All right, and we're good to go. All right, let's move on to number 3. I have lithium bromide plus magnesium oxide. So I have a compound plus a compound. All right, let's take a look. All right, when you have a compound and a compound, it'll go with double replacement. So these 2 compounds are going to come together and they're going to switch partners. All right, so double replacement here as well. All right, so what's going to happen? Lithium is going to take the oxygen. Magnesium will take the bromine. So the outer 2 will come together and the middle 2. Just be careful of your cation, anion placement. All right, so when lithium and oxygen come together, the compound formed is Li2O because oxygen has a -2 charge, or oxide ion does. Plus, so magnesium bromide will look like this, MgBr2, because magnesium as an ion has a +2 charge. And we did say double replacement. All right, now I need to balance. I notice I have double the lithium on this side as I do over here. I also have double the bromine on my product side. So I'm just going to speed through this, and I see that by putting a 2, doesn't really look like a 2 out front of my lithium bromide compound, I now have 2 lithium, 2 bromine, 2 lithium, 2 bromine. My magnesium and oxygen numbers are good. So we're going to carry on there. All right, number 4, calcium plus oxygen. So that's an element plus an element. So you guessed it, that will be a synthesis reaction. So when calcium and oxygen come together, they form a specific type of compound. That's an ionic compound. So we need to know our knowledge of the charges that these elements would form when they became ions. So calcium will have a +2 charge because it's in the alkali earth metals, and oxygen will have a -2. So when we crisscross, our compound will be CaO. Now note, you're thinking it should be Ca2O2, but when we're balancing chemical equations, we need to reduce. Okay, now I need to balance, and we did say this was a synthesis reaction. I about spelled it out. I have double the amount of oxygen on my reactant side as I do on my product side. So I'm going to stick a coefficient of 2 out front. So I now have 2 calcium, 2 oxygen, so my oxygens are good. Now, to fix the calciums, I'm going to stick a 2 out front of my calcium. All right, last one. CH4, its name is actually methane, don't have to worry about that one, plus oxygen. One thing to note, so you're probably saying, okay, this is a compound plus an element, single replacement, right? No. There's something special about this type of a compound. It is made up solely of hydrogen and carbon atoms, so it gets called a hydrocarbon. So anytime a hydrocarbon or a compound containing only hydrogen and carbon, when it reacts with oxygen, it produces carbon dioxide and water. All right, so I'm going to write CO2 plus H2O. This is a combustion reaction. I'll just spell it out. Why not? All right, now I need to balance. 1 carbon, 1 carbon. 4 hydrogen, 2 hydrogen. 2 oxygen, 1, 2, 3 oxygens. All right, so I need to fix this. I'm going to try and fix my number of hydrogens first. So I'm going to stick a 2 out front of my water. So I now have 4 hydrogens, and I now have 1, 2, 3, 4 oxygens. So to fix my imbalance, I'm going to stick a 2 out front over here. Then I'm going to double check, like we meant to do over here. 1 carbon, 4 hydrogen, 4 hydrogen, 4 oxygen, and 1, 2, 3, 4 oxygen. Alright, that's all there is to it. Continue to practice this on your own. Try the starters and finishers, and as always, ask me questions.